In this video, we're going to talk about chemical formulas and how to write them. What is a chemical formula? Chemical formulas have to do with representing molecules and compounds. They are a shorthand way to show exactly what elements are in a compound. When we write a chemical formula, we use the abbreviations from the periodic table. For example, H for hydrogen, O for oxygen, K for potassium, S for sulfur, Na for sodium, Cl for chlorine. And we stop there if there's only one atom present in the compound, but if there is more than one, we use a subscript to show. For example, when we write water, which is a compound of one oxygen atom and two hydrogen atoms, we write it as H2O, as you probably already know. And then there is another compound, potassium sulfate, and there are 2 atoms of potassium in that and 4 atoms of oxygen, and so we would indicate it in that way. In this way, we can carefully count how many atoms there are in any compound. If we were to count the atoms in water, we would count 2 hydrogen atoms and 1 oxygen atom, so water has 3 atoms in it. If we were to count the atoms in sodium chloride, we would count 1 atom of sodium and 1 atom of chloride. There are only 2 atoms that make up this compound. Can you see how important it is to use the capitalization rule? Because there's only 2 capital letters in this formula, we know that there are only 2 elements present. K2SO4 is a little bit more fun to count because we have 2 atoms of potassium plus 1 atom of sulfur, which makes 3, plus 4 atoms of oxygen, for a total of 7 atoms that come together to make that compound. Sometimes you might see parentheses used in a chemical formula, like this one. This is the formula for a compound known as calcium phosphate. We know that calcium is an element, but why is phosphate in parentheses like this? Phosphate is in parentheses because it's a little cluster of atoms that have a particular structure. We might even say that phosphate is a little cluster of atoms that travel together. And so by using the parentheses, it shows that they are together rather than just distributed throughout the compound. So let's count the atoms in calcium phosphate. How do we do it? Well, we know how to count these. In calcium, there are 3 atoms of calcium because of that subscript. But phosphate, there are 2 phosphate clusters, which means there are 2 PO4s in the compound, which means that we have 2 atoms of phosphate and we have 8 atoms of oxygen. Notice that's just the same as using the distributive principle to apply the subscript outside the parentheses to the atoms that are inside. 2 times 1, there's an understood 1 here, 2 times 1 is 2, 2 times 4 is 8, which means that there is a total of 13 atoms that make up 1 molecule of calcium phosphate. Now, it would be perfectly okay to write the formula without the parentheses, but look what happens. You just lose the information that you have 2 phosphates, 2 little groups of phosphates, like little gypsies, traveling together. Up here, you can clearly see, and so by convention, we use the parentheses so that we can see some of the structure of that compound right there in the formula. So what's our takeaway? Well, chemical formulas are shorthand ways to write exactly what elements are in a compound or a molecule. They use subscripts if there is more than 1 element present. They use the element abbreviations that are in the periodic table, and you might sometimes see parentheses.